This is Higher Order Derivatives by Harsh Patel. Now before we begin, remember derivatives provide the instantaneous rate of change at any given moment of a function. In this function, f prime, or the green line, is the instantaneous rate of change when x equals negative 0.5. Now this topic discusses higher order derivatives, which occur when you differentiate a derivative of itself. This can be done by using the power rule, quotient rule, product rule, or chain rule, as we already know. In this case, we'll focus on the second derivative the most. As of now, we find the first derivative, set it to equal 0, and figure out the critical points. From there, we plug in the values across the number line to see when the function is positive or negative. To do this, we're able to figure out whether it's a max or min. In this case, there's a minimum at negative 2 as the slope is decreasing then increasing, and a max at 1 since the slope is increasing then decreasing. Now, the second derivative can be found by differentiating the first derivative. Using that, we'll figure out when a function is concave down, which you can remember because it won't hold water, and when it's concave up, because then it can actually hold water. This lets us double check the maxes and mins. Now we want to figure out and find the point of inflection, or when the curve changes direction. In the graph shown, you can see that the curve changes direction as we transition from the max to min due to the change in slope. Between those two areas, that red circle shows a spot where the direction changes, and that would be known as the point of inflection. We can find it by setting the POI and the second derivative as 0 and solving for x. From there, we put them on a number line, and if the second derivative is positive, then at that point it's concave up. And if it's negative, then at that point, the function is concave down. So now when we find the critical points, we can figure out if it's a max or min by knowing whether it's concave up or down prior to or after that point of inflection. So once again, first we use this check for maxes and mins, we find the second derivative, solve for x when the second derivative is equal to 0, and then input the values on a number line to check when the function is concave up and down around the point of inflection. Thank you.
Created using Powtoon.